When talking about air handling unit, we have to consider multiple factors. And what you'll see here, this is an air handling unit which extracts air only from outside. I mean, it's using only the fresh air and then is exhausting the entire quantity of air that brings inside the room. So you'll be subject to an air change rates. And if you look careful, zooming into it, you'll see there's a lot of sensors which collect data, and the data goes to the PLC, so the PLC will control this air handling unit. Now what you'll see here, it's the air circulation through the air handling unit, and this air handling unit have 3 motors. Later on you'll see they will be colored in red because they are a source of heat. So these plug motors actually are a source of heat. So you have 2 heat exchanger in this case, 3 motors onto the supply, and you have 2 extract fans. Each of them have 2 motors. We try to control the absolute humidity, the temperature, and the pressure. Now you can see how the air handling unit looks inside. We take air from outside, like where you see it's a fresh air intake, and the fresh air intake have its specific absolute humidity, which is governed by the nature. Nature have infinite possibilities, so we'll never be able to wait until the nature will provide the right quantity of moisture into the air to have a perfect condition. So that's why we use a cooling heat exchanger. Now this cooling heat exchanger have the capability not only to cool the air but to remove the moisture through condensation. That's why later on you'll find out that if you'll push more air than this heat exchanger can support, the moisture removing capability will be reduced. Now the heat exchanger, it is cooled by glycol which circulate through these pipes. So glycol is very important because the glycol temperatures and flow rates will be an important part of the heat exchanger's capacity. So if you have a bad flow on a glycol or a bad temperature, that will be seen onto this heat exchanger. All I try to achieve here is just to put some sensors and to control the humidity, the ratio. So coming back to this story, you see the air is passing by to the heat exchanger and will drop the humidity after the heat exchanger through condensation, and the water is eliminated via the drain pipe. You can see it. If we will have a bigger quantity of air, or if the coil will not be, the heat exchanger is not cold enough because of the glycol temperature or glycol flow, or maybe it's too much air to heat exchanger, then you will not remove any moisture from the air, and then the process will be very bad. So this is about short video, and now I want you to continue to watch this video to see that there will be an impact if we have an incorrect air change rates, and I want you to look in the calibration. Dear friends, there is a little bit of difference between a domestic electrician and an electromechanical engineer, because this guy make a mistake. He just played with the star delta. So all the fires, but this time it was just a dream. So let's keep it this way. The air handling unit is meant to control the temperature, the humidity, the pressure cascade, and the air change rates. So this is the air handling unit. As you'll see, it takes air out from the production and recirculating through a set of heat exchangers and then brings it back. Let's see now how the air circulates. What you'll see here, the air is passing from one room to another and from the HU into the rooms. On the following video, I want to show you how we can achieve this and some mistakes related to calibration. So let's look closer. This is the AHU, and what you see with red, the red represent all the area that needs to be monitored. The airflow in an air handling unit must be controlled, and for this we use automation. We use differential pressure modules, differential pressure control, which controls dampers, and also the information go to the PLC, which control variable speed drivers. You can see in this video that the DPM collect information through these two pitot tubes and send the information to the PLC, which controls the fan, and send the information to the human-machine interface. I will zoom a little bit, and what you will see, the air passes by through these two tubes, which send the information to the differential pressure modules, which send the information to the PLC, and the PLC send this information to the human-machine interface. Unfortunately, sometimes when we do calibration, we calibrate only the DPM, and we want to say have the same value in between the calibrating tool, the DPM, and the HMI, ignoring the tubes which collect data directly from the duct where the air it is moving, and this is very wrong. By calibrating only the DPM and not doing a loop calibration, we make a big mistake. Sometimes the pitot tube can get contaminated, and when we will reconnect these pitot tubes to the differential pressure module, we might have big errors in reading the pressure or the air velocity. So how can we overcome this problem? I suggest that we do a loop calibration. We will connect the differential pressure module to the pitot tubes, and we use a calibrated tool to have a cross-reference in between the differential pressure module and the calibrated tool. In case this tube will be contaminated, as you will see, the differential pressure module will read an incorrect data, and it will not match the data reading by the calibrated tool. DPM's reading must match the calibrated tool reading. We have to choose the right location where we fit our pitot tubes for the calibration tool, otherwise we can disturb the pitot tubes which send data to DPM. In this situation, a big enigma for me is that the PLC and the FEMS takes inputs from the same differential pressure module, so I cannot see how FEMS is independent. However, if these two tubes will be contaminated, you will clearly see that there will be a difference in between the calibrated tool reading and the pitot tube which send data to the differential pressure module. When tubes are contaminated, you will see that the DPM and the HMI and the FEMS have a different value than the calibrated tool. They read different values because the pitot tube which send data to the calibrated tool, it is not contaminated, while the other two are. And then we have a false alarm and incorrect reading. This is the main reason why I disagree with this type of calibration, where we calibrate the DPM ignoring the pitot tubes which send data to this differential pressure module. This is an incorrect calibration. An incorrect calibration will lead to wrong pressure or air change rate reading. The fan can push more air into the ducts, and that will not only affect the change rates and the pressure, will affect the cooling and the heating capacity, or even the moisture removing capacity. I observe with many occasions that people focusing more on the heat exchangers or on the glycol temperature or the glycol flow through these heat exchangers, but we have to consider the airflow through these heat exchangers, and we don't have to push through this heat exchanger more air than it is allowed by heat exchanger specification, because they will reach a saturation point and they won't be able to do their duty. So it is very important to have an appropriate calibration so we control the airflow and will not over exceed the maximum quantity of air that can pass by through a heat exchanger as per its specification. If you remember, I talked before about taking measurements from multiple locations. So here, if we use a bolometer, we take the measurements from inside the rooms, and then the sum of all these outlets should be equal with the measurement I'm doing now onto the supply air duct. Or if I have some losses, then I have to subtract that value. I like to take some readings from the air that is extracted from the rooms or from the fresh air intake duct. Also, I would like to take readings from the exhaust. I always want to know as much as I can about my AHU. Here you can see the heat exchangers, and you know, guys, if you push more air than the heat exchanger can support, and if you reach the saturation point, the heat exchanger won't be able to remove moisture from the air or will not heat the air enough. So every time we do this type of calibration, we have to make sure that we not calibrate only these differential pressure modules or differential control modules, or I prefer loop calibration, and also I prefer cross references with other calibrated tools, because working for pharmaceutical industry, it's very easy to understand that what you do, it is very important, and you cannot just turn the blind eye and to write things in a paper that looks good, ignoring the reality. Because when I've been employed, I've been told that we meant to save people's life. We have to have a safe product. And people try to petition the GMP with the GEP. But honestly, the air handling unit must provide the right quantity of air. And the air quality is also very important. So if we don't have the appropriate control, or if our control is not reliable, then we will not achieve the desired performance, because the control, it is nothing but technicians' eyes and ears. It's like how a microbiologist looks through a microscope to see these micro or nano entities. Me as a HVAC engineer, I need to have all these reading modules in great condition and have to be properly calibrated, because if only one it is wrong, you will be a chain of events, and I won't be able to give the appropriate answer to my managers if they will ask me what is it wrong. This year I decide to work differently. I'm going to extend my working area a little bit. I'm going to keep eye on a calibration guy. It is very important for me to make sure that what these devices will display, it's real. I don't have to have massive errors, because these errors will lead to all sorts of problems. So thank you for watching this video, and I will try to put more videos, but yeah, this might be a boring video, but it is very important. You really have to make sure that your calibrated devices are properly done, and this is it. Now you can watch how the HMI look in the real world. This is just one page, and you can see some data. And can you imagine this data? It is collected from all these probes that are fitted in a duct. So if these probes gives you a wrong information on this display, you will obviously read the wrong information, and you will take action against this information. And it's like, just imagine you're a mathematician, and if you miss one number,